Welcome in Dark Core. Humanity has been wondering for a long time, we alone in the universe? Is there a mind in its vast expanses, born under a different sun and looking at completely different stars in the night sky? On April 18, 2018, the TESS space telescope was launched on a Falcon 9 launch vehicle to search for exoplanets, that is, planets outside the solar system. Almost 4 years have passed since then. What was discovered during this time? Are we any closer to answering one of humanity's most burning, intriguing questions: is there extraterrestrial life? Are we alone in the universe? INTRO, to search for extraterrestrial planets, the TESS telescope uses the transit method, which has proven itself in the Kepler project, which we will talk about in more detail a little later. TESS stands for Transiting Exoplanet Survey Satellite. The transit method uses the particularity that if the planet passes between the star, around which it rotates, and an outside observer, then for this observer the luminosity of this star decreases for some time. This effect, for sure, was observed by many people, a solar eclipse, when the moon passes between our star and the Earth. But in the case of searching for exoplanets, the task becomes thousands of times more difficult. It's all about distance. The moon is only 380,000 kilometers from the Earth. Therefore, for us it significantly blocks the sun, and at this moment it seems like a giant damper. The weakening of the luminosity of the sun is noticeable to the naked eye. But if the distance to the damper is increased by millions and millions of times, then the weakening of the luminosity will be noticed much less. For example, if aliens living somewhere in the region of Alpha Centauri or Tau Ceti were trying to detect our Earth by transit method, then they should have instruments capable of detecting a decrease in luminosity by 0.0008%. Difficult task? Very. But humanity is already capable of it. And this was proved by the Kepler telescope launched on March 6, 2009. It ceased his work on November 15, 2018. And during these 9 odd years, it managed to discover more than 1,000 planets by the transit method. But only 2 of them, Kepler for 38b and Kepler for 42b, Earth-like in size and are in the habitable zone. That is, conditions there should be close to conditions on Earth and will ensure the existence of water in the liquid phase, a key condition necessary for protein life. Note that it's 9 years of research and only 2 potentially habitable planets. Moreover, Kepler, for 38b is located in the constellation Lyra. And this is 470 light-years from us. Kepler, for 42b is located in the same place, but at a distance of 1120 light-years, very far. It is unlikely that humanity will get there even in the distant future. And any contact with a civilization, if it exists, of course, on one of these planets is very difficult. To say hello to each other, it would take at least 9 centuries. Imagine sending a message during the First Crusade, and receiving a response when satellites are already spinning above the Earth. The main task of the TESS telescope is to search for planets similar to Kepler, for 38b and Kepler, for 42b, but located closer. If Kepler was looking for exoplanets at a distance of up to 3,000 light-years, then TESS was looking for no more than 200 light-years. At the same time, Kepler was aimed at a strictly defined narrow section of the sky with an area of 105 square degrees, which is less than even 0.25% of the area of the entire celestial sphere. This area holds the 3 constellations of the northern hemisphere of the celestial sphere, Cygnus, Lyra, and Draco. TESS searches in an area 400 times larger, which is 85% of the entire sky. The search is consistently conducted in 26 sectors. The telescope is most sensitive to exoplanets with an orbital period of less than 13 days, but is able to find objects with a period of more than 100 days. This pattern is understandable. The faster the planet revolves around its star, the more often it blinks and the easier it is to notice this blinking. For this coverage, the TESS telescope consists of 4 telescopes, each of which is a wide-angle refractor with a 24 degrees x 24 degrees field of view, equipped with a 16.8 megapixel camera, for a total of 67.2 megapixels for all cameras. Researchers expect that TESS will discover more than 20,000 exoplanets, of which 5001000 will be terrestrial and even superterrestrial planets with orbital periods of up to 10 months. A superterrestrial type is a planet whose mass is greater than the mass of the Earth, but less than such giants as Jupiter, Saturn, and Neptune. On January 20, 2022, astronomers from the TESS Space Telescope team summed up the interim results for the first 3 years of its work. The number of found exoplanet candidates amounted to 5,210, of which 177 have already been confirmed by observational data from ground-based telescopes. A candidate for an exoplanet is an object that has twice been observed transiting the disk of a star. In mid-2020, the telescope completed its main science program, having scanned about 75% of the celestial sphere, after which it embarked on an extended science program that includes the northern and southern hemispheres of the sky, the ecliptic region, and areas previously observed by the Kepler telescope. Is there anything really interesting in this abundant catch? There is. First, about the first discovered planet. At the end of September 2018, a group of astronomers led by Chelsea Huang from the Massachusetts Institute of Technology announced the first exoplanet discovered by the telescope. The newly discovered exoplanet lies in the bright Pi star system of Table Mountain, about 60 light-years from Earth. Now about the most interesting exoplanets found. In July 2019, it was reported that TESS discovered 3 planets near the red dwarf TOI 270, 73 light-years away from Earth and located in the constellation Dorado, at a small distance from its star. It was especially noted that the star TOI 270 has a very calm temper, which increases the chances of finding life on its planets. Exoplanet TOI 270b, the distance to the star is about 4.5 million kilometers. This is more than 30 times closer than the Earth is from the Sun. The average surface temperature is 255 degrees Celsius. The period of rotation around the star is 3.36 days. The mass is about 1.9 times that of the Earth. Size, 1.247 times the size of the Earth. Exoplanet TOI 270c, the distance to the star is about 7.5 million kilometers. The average surface temperature is 155 degrees Celsius. The period of rotation around the star is 5.66 days. The mass is about 6.6 times that of the Earth. Size, 2.42 times the size of the Earth. Exoplanet TOI 270d, the distance to the star is about 11 million kilometers. The average surface temperature is 67 degrees Celsius. The period of rotation around the star is 11.3 days. The mass is about 5.4 times that of the Earth. Size, 2.13 times the size of the Earth. As you can see, it's not the best combination for the emergence of life. The planet closest to the star is TOI 270b. It is a super-Earth, its mass is only 2 times that of the Earth. But the temperature on the surface leaves no chance for life. The third farthest planet, TOI 270d, has a high, but still not fatal, temperature. But the mass of the planet, and hence the force of gravity on its surface, is 5.4 times higher than the Earth's. A person there would weigh about 400 kilograms. So, if there is life there, then its representatives must be very miniature. Almost immediately, it was reported about the discovery of the star GJ357, a red dwarf, which is located in the constellation Hydra, just 31 light-years away from us, with several planets. GJ357b, the distance to the star is about 5.23 million kilometers. The average surface temperature is 250 degrees Celsius. The period of rotation around the star is 3.9 days. The mass is about 1.84 times that of the Earth. Size, 1.2 times the size of the Earth. GJ357c, the distance to the star is about 9 million kilometers. The average surface temperature is 130 degrees Celsius. The period of rotation around the star is 9.1 days. The mass is about 3.4 times that of the Earth. Size, 1.66 times the size of the Earth. GJ357d, the distance to the star is about 30.5 million kilometers. The average surface temperature is -57 degrees Celsius. The period of rotation around the star is 55.7 days. The mass is about 6.1 times that of the Earth. Size, 1.9 times the size of the Earth. At first glance, given such low temperatures, it appears that GJ357d is uninhabited. But scientists do not lose hope. They believe that if there is a dense layer of atmosphere around the planet, the presence of which should be established in the course of future research, enough heat should linger on it to warm the planet and to have liquid water on its surface. And the most interesting discovery at the moment was announced on January 7, 2020 by the press service of the NASA Goddard Space Flight Center. The red dwarf star TOI 700 in the constellation Dorado, 101.4 light-years away from us, has 3 exoplanets discovered. TOI 700b, the distance to the star is about 9.5 million kilometers. The average surface temperature is 150 degrees Celsius. The period of rotation around the star is approximately 10 days. The mass is about 1.1 times that of the Earth. Size, 1.04 times the size of the Earth. TOI 700c, the distance to the star is about 13.8 million kilometers. The average surface temperature is 75 degrees Celsius. The period of rotation around the star is approximately 16 days. The mass is about 8 times that of the Earth. Size, 2.64 times the size of the Earth. This planet, with its temperature of 75 degrees Celsius, could be considered habitable. But gravity is 8 times greater than the Earth's does not leave any chance. Of greatest interest is the third planet, TOI 700d. By the way, note that the Earth is also the third planet from the Sun. The discovered parameters for this exoplanet are as follows. The distance to the star is approximately 24.4 million kilometers. The average surface temperature is -13 degrees Celsius. The period of rotation around the star is 37.4 days. The mass is about 1.57 times that of the Earth. Size, 1.22 times the size of the Earth. The temperature is definitely uncomfortable. But in the presence of a dense atmosphere, as we said above, there is a chance that enough heat will linger there for life. In addition, over 11 months of observations, astronomers did not record a single flash dangerous for all living things on the surface of this star, which is typical for other stars in which similar worlds were found. This greatly increases the likelihood of life on its surface. As scientists suggest, due to its climate and surface conditions, TOI 700d resembles early Mars more than Earth. Its atmosphere, as shown by a preliminary analysis of the spectrum, should consist almost entirely of carbon dioxide, and the surface of this twin of the Earth receives 86% of the energy that our planet receives. The main obstacle to the existence of life on its surface, according to NASA scientists, may be that this planet always looks with the same side at the star. This can dramatically increase the temperature on its illuminated side, as well as unpredictably affect the nature of the movement of winds in the atmosphere. But let's be optimistic. Maybe just on the border, between the areas where darkness reigns all the time and where constant day blooms, life could exist. And its evolution has already begun, so that in hundreds of millions of years intelligence will appear there. In any case, it is already clearly seen that planets with conditions for life also exist outside the solar system. And, for sure, there are quite a few of them. But for now, the question of whether we are alone in the universe is still open. But maybe it's for the best? After all, the probability of the scenario described by H.G. Wells in the novel, War of the Worlds, is still there. Thanks for watching Dark Core.